Hello, Legacy Sabers, Marsh here. So today we're going to talk about searching algorithms of an array or an array list. Examples of how would you search through. There's two different searching algorithms that we're going to be talking about today. What algorithms exist to search for data inside of an array or array list? That's our essential question today. Now, the first one that you may hear is called a sequential search. Sometimes people call this also a linear search, depends on who you talk to. Assume that you're searching for a key or a value in a list of n elements. A sequential search starts at the first element and compares the key to each element in turn until the key is found, or there are no elements in the list. If the list is a sorted list, in ascending order, let's say, we'll stop searching as soon as the key is less than the current list element. Sequential search literally is this the first, you look at the first element, is this it? Nope, next element. Is this it? Nope, next element. That is sequential search. Literally one at a time you are searching. Here is the code that a sequential search has in it. So a normal, good old run-of-the-mill for loop, and then a if statement inside there. If we find it, we return the value, the index. If not, we'll return -1. Just like you would think your sequential search code would look. Ways to identify this, maybe in code. You're looking for a single loop and you're looking for an if inside there. Pretty simple. Sequential search is what you would write if you are writing code to search for something. Which of these, just a little question here, which of these cause the longest execution of a sequential search looking for a value in an array? So I'm using sequential search, and I'm looking for the longest execution. So I'm looking at the thing that's going to take the longest here. So the first one in the array, nope, that would be the easiest, right? Values in the middle of the array, yeah, it's going to take halfway, right? I'm going to find the value. Last one in the array, yeah, that would take forever, but if it's not in the array, that would be the final straw, right? That would be the final return. So in our case, if the value is not in the array, it's going to take us the longest using a sequential search to find that value. Because let's say I have 100 numbers in there. It's going to take me 100 if statements to identify that it's not in there. The other kind of search pattern that exists is called a binary search. Now, binary searches only work if your array is sorted. So that is something to note, highlight in your notes. We can only do this if our array is sorted. What we're going to first do is we're going to compare the key, the thing we're looking for, to the middle number of the list. If the key is greater, we're going to compare the key to the middle number of the greater subarray. If less, we're going to compare it to the smaller subarray. So what that means is I'm going to cut it in half. We're going to look in the middle. Okay, we should go to the right. Then we're going to cut the right side in half and then keep going. Okay, if the key is not found or there is not a middle number, we will find that there is not the ability. Ultimately, binary search looks like this. So if I have a set of numbers here, and let's say I am looking for the number 5. What will happen is I'll start at 3. I will see that 3 is greater than 5, so that means I have to pay attention to the right-hand side. I will then be comparing these two. Ultimately, I will find the middle, which in our case would be 4. 5 is greater than 4, so that means I'm only going to pay attention to him, and 5 is 5, and I'm there. Okay, so ultimately you're cutting in half and cutting in half and cutting in half and cutting in half until either A, you find it, or you don't. Here is a binary search. Notice we're calculating that midpoint right here. We're checking to see is the key, the target I'm looking for, less than, then that means I'm going to make the end of our data to the middle -1, so that'd be one next door, right? If it is greater, then I want to make the start to the middle +1, which would mean to the right of my what was middle. And if they are equal, that means I return the middle, returning that -1. Ways to find binary search in code. You're looking for a while loop. That'd be the number one thing. And then finding this midpoint would be the two things that I would look for if I'm looking at searching code and I'm going, what kind of algorithm is this? So I'm looking for a while loop and I'm looking for a midpoint being created each time. Again, though, binary search requires you to have a sorted array. So right here, they are looking through this set of values and they're looking for a target of 8. They want to know what's going to be returned by my binary search. So first thing I'm going to do is I'm going to find the middle of my array. So I got 1, 2, 3, 4, 5, 6, 7, 8. Ooh, middle's not going to be nice though, right? So I'm going to have to do, so notice what its start and end are the last index and the first last index and the first index. So 0 plus 7. I'm going to do 7 divided by 2, which is going to give me 3. So I'm looking at index 3. 0, 1, 2, 3. So I'm going to look at 4. 8 is greater than 4, so that means the new piece that I'm looking at is to the right. I'm now going to compare these guys. The middle is going to be 8, which is the number I'm interested in. So that 8 is at 0, 1, 2, 3, 4, index 5. Okay, so we're literally cutting in half, cutting in half, cutting in half until he finds something. So let's suppose that the binary search method is called on an array containing 2,000 elements. What is the maximum number of times that we can be calculating a midpoint? So if we think about it, they're asking us, how many times will we do this at maximum? So it's not 2,000 though, right? Because that would be a sequential search. This would be sequential. We're literally going to do something with 2,000 times. Here's what's going to happen, right? So we start with 2,000. We're going to cut that in half, and we're going to be at 1,000 numbers, 1,000 elements. I'm going to cut that in half again because we're going to find the middle again. Now we're at 500. I got to cut 500 in half again. I'm now at 250. Cut in half. Now, I am not going to be a perfect number here. I'm going to get 62 because we're going to cut in half, but not keep the decimal. Cut that one in half. Again, not a perfect number. Again, not a perfect number. Just cutting in half. Keeps cutting in half. We're down to the last number. So this algorithm, I will calculate the midpoint. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 times. Binary search is definitely a much better search. It is more efficient. It doesn't make you compare as much. However, it does require a sorted array. So kind of a drawback in that regard. The other thing I would say, sequential search has the easiest code to write. So that is why I would pick sequential search maybe over binary search, just because it's an easier set of code. I would write sequential search more naturally. However, binary search will get the job done faster. So if you're looking through an array that has, 5,000 elements, binary search would do a lot better job in your memory of your computer compared to a sequential search. That is the end of our video about searches. I hope you enjoyed searching numbers with me, and I will see you later.